In this video, I'm going to investigate the behavior of these two functions f of x and g of x as x approaches infinity. And maybe we will also look at the vertical asymptotes. So we are looking at the horizontal as well as vertical asymptotes. So what happens to f of x? Let's start off with that. Look at the highest power of x in the numerator, which is 3, and the highest power of x in the denominator, which is 2. What I am going to do, I'm going to rewrite this function. So if I rewrite it, what I am going to do, I'm going to take the numerator and divide it by the highest power of the denominator, which is x squared, and the same in the denominator. Divide both the numerator and the denominator by x squared. If I do that, in the numerator I'll get x plus 3 over x minus 1 over x squared divided by x squared in the denominator. So I have x squared divided by x squared, which is 1 plus 2 over x plus 1 over x squared. So limit x approaches positive infinity is going to be the same as limit x approaches infinity here. So now what's going to happen here? As x goes towards infinity, this is going to go to 0, this is going to go to 0, this is going to go to 0, and this is going to go to 0. So we have a situation where I have infinity over 1, okay, which is just infinity. So this function approaches infinity as x approaches infinity. How about this function, g of x? And we are going to do the same kind of thing. So divide the numerator by x squared, divide the denominator by x squared. Now look, here the highest power of numerator, highest power of x in the numerator is 2, the highest power of x in the denominator is 3. So I took the lower of the 2 and divided both numerator and the denominator by that number, which is x squared in this case. So if I were to rewrite it, g of x is equal to gonna be 1 minus 1 over x minus 1 over x squared divided by x minus 8 over x squared. Now if I were to take limit of both sides, okay, limit x approaches infinity, limit x approaches infinity, this is going to go to 0, this is going to go to 0, this is going to go to 0. So that's gone. So we have something that's like 1 over x, but x goes towards infinity, so the whole thing goes to 0. So the limit of this thing is going to be limit x approaches infinity, g of x is going to be 0. The reason I gave these two examples side by side is this. Note, in the first example, highest power of x is in the numerator. So that means the term x cubed dominates over all the other terms in the numerator. And in the denominator, x squared dominates over all the other terms. But so which approximately behaves kind of like this, x cubed over x squared, which is just what? X. So in the long run, this entire function behaves kind of like the way x behaves, which means x goes towards infinity, so does the function. But on the other hand, on this function, since the highest power of x is in the denominator, what's going to happen in the long run, this x cubed term is going to dominate, meaning that the denominator is going to get disproportionately bigger than the numerator, and consequently bringing down the whole function down to 0. Now, what happens if x goes towards negative infinity? Okay, so g of x. So just I'm going to use this guy again as an example. So x goes to negative infinity, so this is gonna go to 0, this is gonna go to 0, this is gonna go to 0. So it's gonna be 1 over x kind of, but again x goes to negative infinity, meaning that this is still going to 0. However, there may be a change here, so let's see. So in the long run, this function is gonna behave approximately like x, because this is gonna go to 0, this is gonna go to 0, this is gonna go to 0, this is gonna go to 0. So now if x goes towards negative infinity, so the function is gonna go to negative infinity. Now look at the denominators for other asymptotes, which are going to be vertical asymptotes. So in the first one, I have denominator x squared plus 2x plus 1, which is just x plus 1 whole square. And this is going to be 0 when x is equal to negative 1. So it has a vertical asymptote at x equal to negative 1. And this guy has a vertical asymptote at x equal to 2, I think. X cubed minus 8 is equal to 0, right? So that gives me x cubed is equal to 8, which is 2 cubed, right? So x is equal to 2. So that's the solution here. So when x is equal to 2, this function is gonna be having a vertical asymptote. Of course, this is a cubic solution, and equation, it has 3 roots, but we are considering only the real roots, so nothing complex, no complex numbers. So these are real functions we are talking about. So this is how you kind of investigate the behavior of a function as x goes towards positive or negative infinities, or vertical asymptotes where the denominator of the function becomes 0. I hope that this discussion was helpful. Thank you very much.